In this problem, the system is set up so as to show two force vectors, one acting along the x-axis with 3,600 pounds and the other one making an angle of 45 degrees with the x-axis, pulling with a force of 600 pounds. Let me call the first vector F1 and the second one F2. Now we want to find the resultant of the two forces F1 and F2, and that is required by the big truck to pull in the opposite direction. So the resultant is obtained by constructing a diagonal of the parallelogram as shown here. Let me call this vector F. Now we want to find the resultant of the forces F1 and F2. We can write F1 in terms of the magnitude of the force, which is 3,600 pounds times cos 0I plus sine 0j in terms of the unit vectors. We chose 0 degrees here to denote the force vector along the x-axis. F1 is making an angle of 0 degrees. Similarly, we can write the force vector F2 in terms of the magnitude and sine and cosines. F2 is equal to 1600, the magnitude, times cosine 45 degrees I plus sine 45 degrees j. And so this is 1600 times cosine 45 is root 2 over 2 I plus sine 45 is root 2 over 2 j, which simplifies to 800 times root 2 I plus 800 times root 2 j. F1 can be simplified to 3,600 times cos 0 is 1, 1 times I is I, and sine 0 is 0 times j, which is 0. So F1 is 3,600I, F2 is 800 root 2I plus 800 root 2j. We want to find the vector F, which is the sum of F1 and F2, which gives us 3,600I plus 800 root 2I plus 800 root 2j. Combining the I components, we can write this as 3,600 plus 800 root 2I plus 800 root 2j. The idea is to find the magnitude of this vector F, which is obtained by squaring the components of I and adding it to squared component of j under square root.